Welcome back. This video I'd like us to just kind of have a quick refresher about graphing skills, basic data analysis, basic concepts with linear relationship type situations, which is a lot of what we're going to see in our science class. We're going to you'll be going back into the lab, gathering data, putting it into a T-chart where but instead of just saying X and Y, here we're going to actually define what X, what Y, what those are. We'll assign units to them. We will gather that. We'll make sure we have a large enough data set where we can do something with it. It's just a fancy way of saying make sure we got enough information so we can put enough points on the graph. So let's just jump into the video, get a refresher about that, and then get ready for lab. Let's take a look. Welcome back. In this video, I want to take a look at some graphical analysis skills. We're going to use some graphical analysis skills here. And so we have a lab coming up, and it involves us using graphical data. So I figured this would be a good time to give a refresher for those who might need it, right? So let's go ahead. We're going to take a look at some graphical analysis. All right. Data analysis, it's all pretty much the same thing. So graphical analysis applies me to graph. Let's go ahead and get a graph on here real quick. All right, so we got this. There's a graph. And of course we know, this is our X and this is our Y, correct? So there's our Y. So the first thing we need to think about when we sort of graphically analyze data, we know that what's usually going to happen. So I'm going to use a different color. We can sort of send this off. You have an X value, right? And so you typically have a T chart, right? And then of course you have your X and Y, and X and Y are whatever they happen to be in the lab, right? Whatever you're looking at. And so you get some data. So you look at your points, X comma Y, right? And you put some points, and I'm just going to make stuff up. I'm just making stuff up. And here we can see we have positive. Here we can see we have positive correlation, and then of course you know that you would sort of draw a line of best fit right through those points, right? And you want to make sure that you have about the same amount of points on both sides that are as spaced apart as best you can, right? And that gets into the whole best. That's why it's called a best fit curve. Right? That's one of the reasons for it. A trend line, right? What's the trend that you're seeing in this? And of course, we see from this here, right? We see that something like this would be positive correlation, right? And then if it were the exact opposite, if instead of the trend line kind of being up at an angle like this, then we know if it were something like this, if the dots were scattered going down, right? And so let me redo that. So let's see here. So let's get rid of that. So we know that if the opposite is true, if all of a sudden we've got we've got a scatter plot, right? I'm just making stuff up, right? And then we know we would kind of draw a trend line through that. It'll never really look quite that even on both sides, but we're just going to get some dots. You're going to draw a trend line through that, and of course that would then, this trend line here would then represent your slope, right? And your slope represents kind of like the average of what you have from the beginning until the end. At a minimum, for slope you need what, 2 points? So you need the initial and the final. So sometimes you call that slope is delta y over delta x, and so then y2 minus y1 over x2 minus x1. And so you replace y and x with the actual variables for what you're testing out, right? What you have the data for. Love that coffee. So here, of course, this is not positive correlation. When you look at this, you see negative correlation, right? And then of course, if there's no correlation, well, you would get some crazy stuff, right? If you get no correlation whatsoever, right? So let me go ahead and erase that. If we had no correlation, data is everywhere. And so if you try to draw a trend line going up, or you try to draw a trend line going down, or even straight across, like nothing happens. There's no trend. And so here we just call this no correlation. It's pretty simple, right? So remember, that's the basics of all that. Now we just want to figure out, how does this apply to what we're doing in chemistry class, to what we're doing in science. All right. Well, let's take a look at that. All right. So let's clear our board. So let's go back. Let's get ourselves a graph. I want it in black ink. So there's that. There's that. Get rid of that. Come back to here. We know that this is our x. We know this is our y. So let's get ourselves some points on here that we can graph. Got some points, and then you can see that I'm just going with just a positive correlation, right? It doesn't matter. I could have gone with negative correlation. It really doesn't matter. And actually, I'm going to get rid of that point there, and I'm going to get rid of that point there. Just to really sort of highlight and emphasize what I'm trying to do here. Those points would probably be there most likely. I just want to try to emphasize something here. All right? So let's go to red, and we know that what we would do is, so we've got these points here. We would try to draw our trend line in such a way that is reflective as best we can, where we have it's sort of balanced on both sides. There's a more accurate way to do it. This is just training purposes only. All right, so let's go back. Let's go back to here what we have. At this point right here, what we would want to do, go with green. Let's go with green. Why not? Something different. I want a darker green. We'll go with that. Just to highlight just to have some contrast. Well, along this curve, you could grab this point here, the x and the y at this point, and you could grab, say, this point, the x and the y at that point, and your math teachers have already taught you, they tend to sort of teach you, just draw a dotted line down to kind of show that that's where they meet. And as you later on do stuff with trig and calc and stuff like that, you basically see that you have an x and a y component to that line that they call a hypotenuse, right? So this should be looking a little familiar. And so from there you can evaluate, no matter where you are on that trend line, you should still get the same average. It doesn't matter if we go here or if we grab this point and this point. There's an x and a y here, and there's an x and a y here. We should still get pretty much the same value. Within a plus or minus value, that's that whole uncertainty, and that would be based off of the measurement of our tools, right? And that's something we've talked about. So keep that in mind. This is going to be happening with our data. You're going to have a certain data set, but now if we come back down to our trend line here, we realize that there's points somewhere down here, and there are points somewhere up there. That red trend line, it can continue going up, or it can continue going back. And the way this trend line is drawn right here, it looks like it's going to intercept somewhere right around 0, but not necessarily. So the y-intercept is not always at 0. All right, it just isn't. That's why you've been taught that whole y equals mx+b thing, right? Y-intercept is wherever the y-intercept is for that set of data. So what we need to keep in mind is this. Math teachers that I've spoken with, they don't necessarily always use these terms, but in science class there are two very important terms that we use that I need you to be familiar with. So right here, this region right here, All right, and I don't want to use green because I don't want to confuse anybody that what I'm writing in green means only that green X and Y on there. So I'm just going to use the black ink here. All right. Anytime that we're outside of the trend line that we already have, okay, we are saying that we are looking at extra points, right? So that kind of makes sense. So this is called extrapolation. So when we look at points that are above or below, greater or less than what is on the trend line, we are extrapolating. We're extrapolating data. In other words, we're making predictions. What would happen if we went further back, or what would happen if we kept going with this trend line up and up and up and up and up? And that's called extrapolation. You're looking at extra points. Okay? And then right here, where that red trend line is, we're doing something that is called interpolate. We are called interpolate. Interpolate. All right. It looked like a D there. That's why I erased that back. So inter means between. So like an interstate highway is a road that runs literally between states. It connects between states. And so if we interpolate, we're looking at the points in between from the very first point we have right down here to the last point we have right up there, and everything in between. That's what interpolate means. And so throughout lab, whenever we're gathering data that we can put it into a T-chart quantitatively like this, we're essentially going to be doing graphical analysis, and we want to get good, accurate, precise measurements so that our trend line is reflective of what really is there. We've made good observations, good measurements, we recorded that well, and then from there we can make predictions, we can extrapolate. All right? This is everything. These are all skill sets that are going to be happening with multiple labs we're going to be doing. And we're going to be using this, we'll be using this a lot. So, hope this helped. Pause and rewind as much as you need to. It was good seeing you. It's always good talking to you. I'm glad you could join me for another cup of coffee. And I'll see you in lab. Bye. And that's it. Just remember, draw your X and Y, and then you have to make sure that you properly define what your independent, your X, and what your dependent, your Y variables are. Once you do that, the graph's going to take care of itself, and then you just are wanting to step back and go, what's the trend here? Do I see that there's with the way that I've plotted these points, this data, is there a positive correlation? Is there a negative correlation? Does it seem to be scattered everywhere to the point where we can define this as no correlation whatsoever? So these two variables we're looking at, there's no effect from one to the other. You know, the Y is not a function of what's on X. Okay, that's what we're taking a look at. No matter what it is, you just have to define X and Y properly. Once you do that, the data takes care of itself. And then we just use our math skills that our math teachers taught us in algebra. All right? It's always going to go back to that. It's always going to go back to these fundamentals. So please watch this video as often as you need to, just to refresh your memory. And then with anything else that's more detailed, I'll upload more videos for those. So it's good seeing you again. Good talking with you. I don't have my coffee with me. I literally just finished it. So I'll have a cup of coffee next time. As always, stay curious.